Let's take a look at the derivative of some functions that involve cosecant of x and cotangent of x. So as we go through these examples, we will be using various differentiation rules such as constant multiple rule, product rule, and so forth. So let's go ahead and get started. So our first example has f of x is equal to -2 cosecant of x times cosine of x. So we will be using the product rule. First of all, we can notice that -2 is just a constant multiple. So when I go to find my derivative here, f prime of x, it's going to be -2 times the derivative of cosecant of x times cosine of x. Now, we now have a product of two functions, so we will be using the product rule with cosecant of x and with cosine of x. So we end up with -2 times the derivative of the first function, that's the cosecant function. So derivative of cosecant times cosine of x plus the derivative of cosine of x times cosecant of x. So that's what our product rule will look like. So let's go ahead and implement these derivatives. So -2 times the derivative of cosecant is negative cosecant x cotangent x times cosine of x, that was already there as part of the product rule, plus the derivative of cosine of x, which is negative sine of x, times the cosecant of x, which is part of the product rule. Now, one thing we can notice is that we have the negative in front of this quantity and a negative for both terms. So we could distribute that negative sign and turn everything into addition or positive quantities. So we would end up with something looking like 2 times cosecant of x, cotangent of x, cosine of x, plus sine of x times cosecant of x. Now it's time for us to investigate if this can be simplified any further. And that's most easily done by turning the cosecant, cotangent functions into sines and cosines. So we'd have 2 times 1 over sine of x. Cotangent is cosine of x over sine of x times cosine of x plus sine of x times 1 over sine of x. Now, when written in this form, we can see that we can certainly do some simplification on the second term with the sine of x times the 1 over sine of x. But as I look at this first term, I don't see any common factors. And we could certainly leave this in terms of sines and cosines. So we could write this as 2 times, what would it be? Cosine squared of x over sine squared of x plus 1. And then we know that cosine over sine is equal to cotangent, so we could even write this as 2 times cotangent squared of x plus 1. So we could say that the derivative of our original function is 2 times the quantity cotangent squared of x plus 1. Let's look at our second example. G of x is equal to x squared times cotangent of x. We will be using the product rule. As we can see, we have one quantity being x squared multiplied times another quantity being cotangent of x. So let's go ahead and see how this works out. So g prime of x is going to be the derivative of x squared, using the product rule, derivative of the first function times the second function, or cotangent of x, plus the derivative of our second function, in this case cotangent of x, times the first function, which is x squared. So there's our product rule. We'll go ahead and find the two derivatives. So the derivative of x squared is 2x, using the power rule, times cotangent of x, plus the derivative of cotangent of x. Well, the derivative of cotangent of x is negative cosecant squared of x times x squared from our product rule. Now, as we look at this, there really isn't a whole lot that we can do to simplify this up, other than maybe write this as 2x cotangent of x minus x squared cosecant squared of x. And that would be the derivative of our function g of x. I hope this is helpful.